What are the most interesting real industrial use cases for metal 3D printing? In this video series, we introduce applications that are in production and that are create real added value to the user. Today, we start with the stationary gas turbine parts from Siemens Energy. The best way to introduce an application is to talk to one of the leading pioneers of metal 3D printing in this industry. It's a pleasure to welcome Markus Seibold, Vice President Additive Manufacturing at Siemens Energy. Markus, can you give us a brief overview of the additive manufacturing activities at Siemens?
Yeah, hey Matthias, thank you. Thank you very much, first of all, for the opportunity here of discussing that topic with you in terms of real industrial use cases and that they make a real difference for additive. Siemens Energy and additive. We basically have a history of, it's now more than 12 years since Siemens started its first additive manufacturing activities in the metal powder bed fusion site, driven out of our oil and gas team in Sweden, Finspång, and it wasn't long that other sites then came along. Today, we have a global network of 5 sites that are really driving metal additive manufacturing. It's the site in Finspång, it's the site in Berlin, which is our technology development center for advanced additive manufacturing technologies. It's we have in our gas turbine and steam turbine facility in Charlotte, we have also additive technology installed in order to drive rapid prototyping of new designs. And it was 2016 that Siemens acquired 100% stake in Material Solutions, which is one of the world leading service providers and technology companies when it comes to metal additive manufacturing. And today, Material Solutions forms a very essential fourth pillar in our global manufacturing network, with now 2 sites, one in the UK, in Worcester, close to Birmingham. And we recently opened in October 2019, we opened a Material Solutions application center in Orlando, Florida. So it's today 5 sites. We have 180 people at Siemens Energy that really are dedicated to additive manufacturing. They range from technology development to design of additive components. It reaches into really qualification of components for serial production. It goes to manufacturing of those parts through our sites in Finspång and through our site at Material Solutions, so real serial production that those 180 people do. And we have currently 50 plus printers on the powder bed fusion side that distributed across those 5 sites. And of course, we have still then also binder jetting technology, Mark IV printers for tooling and fixtures. So overall, a pretty, I guess, now extensive setup that is driving additive. We currently have 50 plus components already qualified for serial production. So they are orderable in our SAP systems, and we are turning them towards additive manufacturing. We have plans to grow those to over 200 by the mid-2020s. And basically, it's all about now for us driving more and more components into serial production, and secondly, pushing the limits on technology applications. I guess that is, I would say, Siemens Energy additive manufacturing in a nutshell.
Great, thank you. And let's focus those 50 plus applications on one particular application that we also displayed on our report this year. It's a gas turbine main swirler, that's how you name it. And you said it's a critical core part of a Siemens stationary gas turbine. Can you describe a little bit what is this component doing and how did it come to be manufactured additively?
Exactly, a pleasure. So first of all, I guess if we look at a gas turbine in a very, very simple way, there is a compressor that's taken in air and compressing it. Then there is a combustion system, which basically mixes at the end of the day air and gas and burns that mixed fuel. And then after that is the turbine, where the burnt, basically hot gas flow hits the stationary and rotating turbine parts and basically generates mechanical energy, which then turns a generator, which generates electrical energy. And if we're talking about the challenges that our industry faces, basically it's both on the product side and on the supply chain side. On the product side, I guess a few key challenges are, of course, environmental emissions. And oftenly gas turbines are quoted as the greenest of all the fossil fuels, because you can actually substantially lower CO2 and NOx emissions of gas turbines compared to, for instance, coal. So in the combustion system, it's all about more efficient mixing of fuel and of gas and air, and it's all about more efficient burning of that gas, and then of course increasing firing temperatures of the combustion system. And the serial production component, what we call the main swirler, basically is sitting right in the middle of the burner, and its function is, as the name main swirler basically says, it mixes gas and fuel. And then afterwards, this mixed gas and fuel is gas and air is being burned. So it sits right in the burner. It's part of our combustion system, and its function is really key for maintaining environmental emissions low, while we can increase firing temperatures of our gas turbines, which then drive power output and combined cycle efficiency.
So the added value for you, the main added value is you increase efficiency of your final product of the turbine.
I guess that is in general one of the key areas of where we apply additive, and that in that very specific case that we're looking at here, the serial production part of that gas burner, I guess the idea to really take this part and drive it into serial production was actually more coming from the supply chain side, which I mentioned as the second big pillar which drives the use of additive in our industry. And it was really all about reducing complexity in our supply chains and manufacturing operations. Conventionally, that part that we are looking at has been made of 10 different individual pieces. So a lot of supply chain effort to get those 10 parts to the factory, then a lot of manufacturing effort, a lot of welding in order to basically turn those 10 parts into one. And then, of course, a lot of also quality effort in order to certify that this part then conforms with the design intent at the end of the day. What we can do with additive, we basically took the 10 parts and we consolidated it into one 3D printed part, because now you can print those fine additional elements that you needed to weld on top of a structural part. You can print them on top. And so in this case, it's really about reducing the complexity of our manufacturing chain. We are not necessarily touching the core of the performance of a gas turbine with this part, but we have others that do, which are currently being developed and industrialized. And the second main purpose for this part was really, we wanted to, in quotes, learn how to industrialize. How do you turn additive on the metal side from R&D into serial production? And for this, you need always the first pilot part in order to really learn what you don't know yet. And so we took this part also in order to turn this into a serial production part. And then subsequently prove that additive is capable for serial production, that we can get consistent quality out of the printers and the post-processing supply chain, and that we also can meet delivery requirements such as cost and on-time delivery internally. So for us, it was to learn how to industrialize, and it was drive adoption in a wider company.
Okay. And what means serial production for you? How many of those parts are manufactured today or in the future?
On that very specific part, that is basically on our large gas turbine sites, which are mainly used for the central power generation sites. There is one of those on every single gas turbine that we have. And we are now working through our gas turbine portfolio, and we will convert all the swirlers that we have on our gas turbines now to additive. So we are almost talking about a part family. It's, at the end of the day, it's an in-canal material that we are processing here. It's 8 of these swirlers is sitting on one burner, and then depending on in which region of the world, 50 or 60 hertz, we are selling a gas turbines either 12 or 16 burners. So it's basically around about 100 plus swirlers per each of our gas turbines. And this is also a service part. So that part needs regular servicing and upgrade. And so we are talking about a couple of thousand of these parts a year that are currently being industrialized and produced at Material Solutions in the UK. And if you currently would walk into Material Solutions, we sometimes call it now a factory full of swirlers. So you basically now see really swirlers flowing through the entire factory, from printing to machining to quality inspection, and before, of course, depowdering, and then to final inspection and goods out. So we really now see that this part is what many talk about. It's a serial application. There is a factory full of swirlers at Material Solutions, and we need to deliver now on time, on quality, and on cost to our internal customers. And that's I guess the main difference that we see with this part now. It's not R&D anymore. It is true serial production.
Right. And if you look at the machine technology you're currently using, you said it's about 50 plus systems, but I would assume not all the 50 are in the serial production stage yet. But if you look at the machines we are working with today, especially the powder bed fusion machines, and their performance and the supply chain behind additive, are there things that you see are working very well, and are there other things where you see there's big room for improvement, where you would set the bar higher in the future for those systems?
Definitely. I mean, it's to some extent it's also inherent in the maturity stage, considering the maturity stage of the industry. And since this application we're talking here about is now a representation of a current step that at least we see for us on the user side happening right now, the transition towards serial production, also the machine technology vendors now also need to basically go with us as a user on that next phase. I think what really works okay in the industry right now is, in general, I would say the machine tool makers are providing now machines that fit more to our requirements. You've seen in the past years that the build chambers grew bigger, and you had also the multi-laser machines, I guess, were the big advancement, I would say, when we're talking about powder bed fusion. And that, in the end of the day, drives productivity, multi-lasers, and the bigger build chamber, of course, drives productivity, cost of part, and also it unlocks new application spaces. So I guess that really was very helpful for us, because now we can consider to print certain applications which we couldn't even make a business case of on the former smaller machine generation. So that was actually okay. I think what the machine tool maker industry has gone through the last years is also a little bit of a calibration. And if we go back to some of the conferences 2 years ago, there was a lot of talk about that the future of additive is a fully digitalized and automated factory, and it's all about digitalization, automation. I personally do believe, and I guess we as a user, Siemens Energy, we believe that this is, I guess, step 3 that should come. I guess there is 2 more important steps that we need to be in place before we talk about digitalization, automation to be really relevant for driving serial production. Number 1, the machines need to be more reliable. And we are measuring usually machine tools in grades of serial production readiness based on the OEE model, the overall equipment efficiency model. And when we do currently our capacity planning of the load increase that we see coming from our serial production curve, and we match it with our capacities, one of the biggest or the biggest challenge we face now, and we need the machine tool makers to help us to respond to, is we need to increase the OEE of those machines, the availability of those machines, so that we can increase utilization. Because otherwise it's just becoming too expensive on the overall factory result if you have all those machines that are not utilized in the high double-digit, very, very high double-digit percentage rates. So that's number one. Number two, we still need innovation on those machines. In our case, stationary gas turbines, we need a bigger machine still. We have a lot of unused application potential because still the current large machines are not large enough. So we need bigger machines. And we also need to understand how we can further drive productivity of those machines, because cost is still a hurdle to adoption. And thirdly, on the innovation side, we need new materials. We need, if we want to further push the boundaries, we need to unlock new applications. And this also means that the machines need to get bigger, yes, but also we need new materials. So that's priorities number one and number two. And then number three, of course, it's all about, of course, then efficient production, serial production. It's about automation. It's about integrating the technology into workflows. But I've seen in the industry now that 2 years ago, I was a bit concerned because everyone was talking about digitalization as the big thing that will be pushing this into serial production. And I believe, number one, serial production readiness, and number two, innovation is far more important for us in order to make steps into serial production than it is about digitalization right now. Digitalization will become important, but only after we solve number one and number two.
All right. We talked a lot about powder bed fusion now. There is a lot of new technologies coming up in the market, and we see DED technologies in several different stages, and especially around binder sinter-based technologies, there's quite of a hype in the past 2-3 years, generated mostly by American companies. Do you see a chance for those technologies to add value in the gas turbine industry? Do you see applications in your, let's say, highly regulated industry, in an industry that requires high part quality and material properties?
I guess there is one thing is for sure, there is not only one single technology that will be relevant, considering also the growth cycles that this industry will go through. So it would be very, I guess, ignorant to say it's only powder bed fusion, nothing else. So I guess we do not believe that. Today, powder bed fusion adds the biggest value to us. And that is because you can really produce those geometries that you couldn't make conventionally. And this is what unlocks value at the end of the day. Value in form of emissions, value in form of efficiency, value in form of consolidation of different parts. So that's why we focus so much on powder bed fusion. We nevertheless, I guess we are doing additive manufacturing for more than 30 years, I would say, by applying DED, which we called, I guess, laser metal deposition, LMD in the past, for repair applications. So we have qualified repair processes where we do a DED repair on turbine parts for, I guess, now many years already. And we just didn't call it additive before the big hype came. We also are exploring other technologies to build larger structural parts. Wire arc is one of those technologies we are exploring a bit. And binder jetting is, I guess, the current fast-growing new technology. Yes, we are looking into this. Of course, the major advantage then would be cost reduction on smaller parts. We do see potential application areas. We are running studies in terms of looking at the potential of binder jetting to drive cost reductions on smaller parts and on even sometimes building fixtures and toolings. And this will be relevant. I guess just if you compare it from an overall value to the business perspective, powder bed fusion still remains the biggest value driver because you're touching the core of what makes our product competitive. But yes, we are looking into alternatives. We have studies running on almost every single other technologies, and we will decide based on the progress and based on the business cases when to invest also into alternative technologies, which we are doing already today.
Okay. And Siemens is probably one of the larger companies implementing additive, and you're mostly talking about Siemens Energy, but there's of course also the whole Siemens group behind that. How do you manage to implement the knowledge company-wide? I mean, you have probably a group of experts, you said about more than 100 people working in this field now that probably are all experts in their field, but you need to probably implement the knowledge in a whole engineering team company wide. And can you share best practices how you can do that, how you can spread the knowledge and enable the engineers to think additively?
Sure. I believe, and this is now, everyone can of course structure it a bit differently, but basically what we developed is a bit, and what I basically think has been one of the key success factors for us, is we're looking at this in two different dimensions and basically 4 different fields. So the 2 different dimensions is really, is it technology related, so basically the hard facts that you can quantify, or is it rather on the softer side, business models, culture, etc. And then we look at this from the dimension of internal focus and also external focus and partnerships. And I believe what is needed if you want to drive a new technology like additive into a very demanding, risk focused and value driven industry, and this is not only for power generation, but also is true for automotive, that is true for aerospace, you need to address 4 different things. You need to address the technology. You need to invest R&D budget, and you need to deliver material properties. You need to qualify machines. You need to learn how to design for the technology, etc., etc. That's, of course, that's without that, that's, I guess, almost the cost of sitting at the poker table. If you don't do that right, you will not be successful. The second element then is, if you're in a regulated industry, you need to be able to qualify and certify your technology to authorities or to your customers in our case. So you need to understand how you can manage process repeatability, how you understand quality defects and correlate them back to part performance. And you also need to comply with formal certification requirements. So that's the second thing. That's, I guess, 2 very tangible to hard tech topics. I believe one of the key reasons why we were really successful, and today I guess I would consider us as one of the leaders in application of additive manufacturing, is we did not stop at those 2 hard fact items. We also looked into the 2 softer fact items, and I guess those 2 are collaboration and business models and culture. And I believe specifically culture plays a very, very, very critical role when it comes to adopting a new technology. And we've broken it down into a few levers that we've addressed. It starts with executive sponsorship. You are in a continuous competition internally for R&D funding, and you sometimes need people to just hold a little bit their protecting hand over your heads so that you have time to work 2 to 3 years on finalizing an application such as our serial production part. It's not going to be a 1-year thing, but big companies always work in 1-year budget cycles. So you need executive sponsors. That you need to earn yourself those executive sponsors, and they need to protect the investment into additive. Together with that, I guess you need to be very clear about the purpose of additive for your business. Is it going to be a cost reduction game? Is it that it's going to be helping your sales guys to win in a competitive market by able to offering more competitive product in terms of performance? Is it a supply chain topic? Is it a service topic? You need to be very clear what the purpose is of additive, because that purpose drives R&D investments and then needs to manifest itself in the portfolio strategy of your company. So I guess it's the 2 top level things. Then if you take it further down, it's many of our product owners are the ones that at the end of the day decide whether or not a serial production additive component goes on one of their products or does not go on the product. So it's not the executives, it's the product owners, the famous mid-level managers. And they are not driven by making additive a success. They are driven by making their product successful. And they have concerns like cost of the product. They have concerns like risk that additive is adding to their product. So you need to understand the concerns of those mid-level product owners, and you need to have plans in place, specifically how you can mitigate the risk for their products. And we've been really focusing on that. So one of my biggest times that I spend on, I spend stakeholder management. So I try to understand the risks, I try to understand the drivers, and so that we can cater to them. And the other thing we did lended ourselves credibility internally. So we did not only pursue our roadmap based on what the additive team thinks. We asked experts in the company to look at our plans, to challenge our assumptions in terms of material performance. And the fact that we actually asked neutral, internal, credible authorities like principal experts or senior experts or former heads of engineering gave our plans a lot of more credibility. And so by sometimes you need to actually expose yourself to a lot of critical questions, but then you get credibility from it. And you need to, at the end of the day, last thing, you need to celebrate successes. I guess one of the highlights for our team was when Joe Kaiser, our CEO, 2 years ago at the General Shareholder Assembly, wanted to emphasize to his investors and shareholders that Siemens takes R&D and innovation really, really seriously. And he basically had a 3D printed turbine blade in his hand that he showed to the entire shareholders of Siemens AG as a proof point for how we drive innovation in the company. So you need to celebrate successes. And I guess this is specifically the last topic, this topic of culture. And in our case, it's those 5 levers that we sort of converge to, is, in my view, mostly underestimated because people tend to focus mostly on the technology. But it's equally important than technology if you want to drive adoption in a multinational, multi-business unit corporation.
Okay. So I think that the focus has to be to include all the stakeholders, not only the ones that are related directly to the technology, directly to the application, but also all the other stakeholders around the companies that are affected by the technology, right?
That, and I guess you need to almost put yourselves in their shoes, because you as Team Additive, your mission in work life is to push additive into serial production. The mission in work life of a product owner is to deliver a product. He almost doesn't care if you use additive or not, as long as he meets his targets. So you need to be able to switch perspective, understand the concerns and the drivers of your internal customer, and then factor those into your plans. And I guess that's what I mean with culture. And it's not only just about the facts of your material. It's also about, does he have a schedule risk? Does he have a risk of his product then not performing? And can you mitigate it somehow? So I guess it's about stakeholders, but it's about putting yourselves in the shoes of those stakeholders.
Okay. Thank you very much. I think that was great lessons learned, great input and great insights from you, Markus. Thank you very much. I think what we saw today is that metal 3D printing is capable to add real value from a technology, but also from a commercial perspective. And that's a very important point. We know that about almost 1,000 metal AM machines are currently running in the energy and gas turbine industry in total. And more of them are under qualified conditions, producing high value parts, mostly in nickel-based alloys. This industry has the second highest utilization rate of its machines, and we expect this number to grow even further in the near future. Thanks for watching this video. Don't forget to subscribe to see the next video focusing on a different industry, and see you next time.